Alright guys, today we're going to be solving a system through substitution and through graphing. Now what we're going to do is we're going to be looking at this one that's both a quadratic and a linear. Now I want you to recognize first and foremost that the process we're going to go through is no different than what you did for linears. When you had two linear equations, how did you do graphing? Well, you graphed one, you rearranged it so that it was in a format suitable to graphing. You graphed that equation, then you did the other equation, you got it into a format suitable for graphing, usually y equals mx plus b. And once you had it in that format, then you graphed it, and then when you graphed the two lines, you found the intersection, and that was the answer. We're going to do the same thing here with graphing. Then we're going to do substitution. With substitution, you remember that you had to rearrange it to isolate a variable. And it didn't matter whether it was x or y, but you isolated a variable. And then you substituted in the other equation. Right? Now this is what you did. And then once you substituted, then you solved for the variable. Once you had the variable by itself, and you knew what the value was, then you took it and you put it back in to solve for the other variable. Right? And hopefully what I just said and what I just wrote down kind of makes sense along with what you've been doing in the past. Okay? With linear systems. We're going to do exactly the same thing here. Alright? Now let's go ahead and we'll do substitution first, just because most of you like substitution better than graphing, and I'm with you there. So substitution, we first isolate the variable. Hey look, y is all by itself. Done. I don't have to do anything else. Y is already by itself. Then I substitute in the other equation. So instead of y, I'm going to put 7 in for y right there. So I'm going to have 7 equals x squared minus 9. We then solved for the variable. Now the variable here is x. How do I solve when x is squared? Well, I get everything over to one side so that it's equal to 0. And then once it's equal to 0, I can either use the quadratic formula or I can factor. I recognize this 16 as being 4 squared, which makes this x squared minus 4 squared, which is difference of squares. Remember that a squared minus b squared factors to a plus b, a minus b. So then you've got 0 equals x plus 4, x minus 4. So then we go ahead and solve. We say either x plus 4 equals 0. Remember, two things are multiplying together to give me 0. One of them's got to be 0. So then we go x plus 4 is 0, or x minus 4 equals 0. And you'll notice that that then gives me my final answer of x equals negative 4. And adding 4 on this side to get x equals 4. Now remember, that's just solving for the variable. I'm not done yet. I am looking for the intersection of these two equations. So now I've got to go take that number, put it back into the equation to solve for the other variable. Well, I know that x is negative 4. I actually already know that y is 7, but let's go ahead. We'll take the negative 4, put it back in. So I'm going to put it back into the quadratic just because I can. So I'm going to go y equals negative 4 squared minus 9. Negative 4 squared is 16, and 16 minus 9 is 7. So when x was negative 4, y was 7. And I do a similar thing with the 4. Hopefully you'll recognize I'm going to get the same thing there. Again, 16 minus 9, which is 7. And so when x was 4, y was 7. Now, of course, at this point, the best idea and what you should do in your homework is make sure that those points actually work. Put in negative 4, 7, 4, 7, and make sure that it actually works in both equations, that it really is a solution. All right? So there we go. That's substitution. That's all there is to it. Now, what are we going to do next? Well, we're going to go ahead and do graphing. Now, for graphing, it's completely different. So everything that I just did, oh, it didn't go, whoa, why are you doing that? Whoa, okay, let's get rid of it. There we go. Okay, all of it's got to be gone. Because none of this is important for graphing. Graphing is a completely different method that we're going to use. So once all of this stuff is gone, then we're going to go ahead and we're going to do graphing. Now, graphing will be a little bit easier in this question just because I got y equals 7. Now, y equals 7 means that everywhere on the line the y value has to be 7. So I can definitely see that y is 7 there. As I move to the side, y has to continue to be 7. So that's actually going to be a horizontal line, just like this. Okay, so that is graph. Now I need to do y equals x squared minus 9. And so let's go ahead and graph that one. So the first thing we're going to look for is the axis of symmetry. And the axis of symmetry is at x equals negative b over 2a. Remember, this comes from ax squared plus bx plus c. C is the number at the end, so that's negative 9. A is the number in front of the x squared, which is 1. And b is the number in front of the lone x, which there isn't 1. So b, therefore, has to be 0. So this is going to make it 0 over 2 times 1. When I work that out, I get 0. That's the x value, which then I put back in. I'm graphing the quadratic, so everything goes back to the quadratic right now. So y equals 0 squared minus 9. So y will be negative 9. So that's my vertex, 0, negative 9. I'll put that on my graph. I also have, of course, that my axis of symmetry goes down at 0 right here. So that's the mirror that I'm going to deal with later. Well, I note that this also just happens to be my y-intercept, so I'm not going to look for y-intercept this time, but I am going to look for x-intercepts. So to get the x-intercept, I'm going to make y equal to 0. That's how I get an x-intercept. So I go 0 equals x squared minus 9. And we notice that this is the difference of squares. So it's x squared minus 3 squared. So that will factor to x plus 3. X minus 3, still equal to 0, of course. Now I've got two things that multiply together to give me 0. So I've got x plus 3 equals 0, and I've got x minus 3 equals 0. I subtract 3 from both sides, and I get x equals negative 3. This one I add 3 to both sides, and that will give me x equals positive 3. Now these recognize are x-intercepts. So I put down 3 and negative 3. So right there. And negative 3 right there. And then I note that I have 3 points here. Now a quadratic, to be a nice quadratic, should have at least 5 points. Now remember before, once I ran out of special points, axis of symmetry, x-intercept, y-intercept, once I did all those, I could always just put in a number and get another point on the graph. Now I'm going to choose my point wisely. Okay, I know what this graph should look like. It should be a U shape, right? The x squared is positive, so it should be a U shape. Should look something like this, right? And I kind of sketch it in. It should look something like that, which means I expect it to cross the graph somewhere up here, right? And somewhere up here. So somewhere around x equals 4 or 5. Okay, so I'm going to go ahead and put that in. I could just as easily put in a 1 or 2, but that would give me points down here, which really don't help with my intersections. So I'm going to go ahead and say, well, what if x equals 4? I'm going to put that in. So I'm going to go y equals 4 squared minus 9. Remember, I'm focusing on the quadratic. I'm still graphing my quadratic here. So I'm going to get y equals 16 minus 9. Which is 7. So when x was 4, y was 7. So I can go to 4, 7, which is that intersection point right there. And of course, I can reflect that onto the other side. Now I've got a nice quadratic graph just like this. You can see the whole parabola there. And not only that, but I did just happen to get my two intersection points right there and right there. And so I now have my final answer, which you'll note is the same as last time when I did it by substitution. 4, 7, which is this point right here, and negative 4, 7, which was this point right here. That's question number 1. Why don't you try number 2 on your own?